There we are. Welcome to the February 5th meeting. You can reach us through various means. You can reach our center through our website at halifax.rasc.ca. We have a YouTube channel that also has our videos from previous meetings. And just to advise people that we are recording this, and it will be posted in a few days once our power is up and functioning. Again, it will be on our website. If you have any questions or concerns, you can certainly email me at president@halifax.rasc.ca. We'd like to begin by acknowledging that we are in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the treaties of peace and friendship with Mi'kmaq and Maliseet peoples, first signed with the British Crown in 1725. The treaties did not deal with surrender of lands and resources, but in fact recognized Mi'kmaq and Maliseet title and established the rules for what was an ongoing relationship between nations. I'd also like to inform people that RASC and our center believe in and practice inclusivity and diversity. All are welcomed regardless of age, disability, gender reassignment, marriage and civil partnership, pregnancy and maternity, race, ethnic origin, color, nationality, national origin, religion or belief, or sex and sexual orientation. We are opposed to all forms of unlawful and unfair discrimination. If you aren't a member of RASC, which I think the vast majority of people here today are, but if you are not, there are certain special benefits. From the national perspective, by joining RASC, you get the annual edition of the RASC Observer's Handbook, the Explore the Universe Guide, and subscription to Sky News. You also get the journal. You also have the opportunity to receive the e-version of that if you so choose. There's the RASC Bulletin and the RASC newsletter that come out to every member, and certainly there's an archive of the center newsletters, not just ours, but others as well. You also have access to the RASC Awards, the observing programs and their certificates, special presentations that RASC has, publications such as the Observer's Calendar and John Reed's books, which are also available. One of our own members who writes several books about astronomy, his books are available through this site. Discussion lists and special deals on insurance and liability insurance on various things. When you join, make sure you affiliate yourself with our center. And when you do, you have access to our Nova Notes, which is our newsletter produced 5 times per year, our discussion list, announce list, and certainly our center resources of library and our St. Croix Observatory. And the most amazing thing is that you get this incredible group of astronomers and mentors, professional and amateur, new and experienced, astrophotographers and sketchers as well as the visual observers. So come join us if you haven't already. There's astronomical camaraderie awaiting you. So today's agenda, we've already concluded the welcome. In a moment, I will close this off and Paul Gray will take the photo montage. Our 2 special guests today, Dr. Jennifer West will present Inside the Galactic Tunnel in the Sky. And Tim Doucette will be doing an equipment review on a piece that, interestingly enough, this past week, Celestron says, we now have in stock. So once you hear what Tim says, you can determine whether or not you want to go to their site and purchase. What's missing from here, and I apologize to Paul Heath, is there will be the Food for the Soul. His poem, his monthly poem will be up. And Dave Hoskin, observing chair, will then do the What's Up in the February Skies, and I will conclude with the news from the board. At which point the recording will be closed, and those of you who wish to stay on for an informal Astro Chat afterwards, which is not recorded, are certainly more than welcome to join us, so please do so. So at this point, and that's the beginning of my presentation, Paul Gray can now go ahead and do his presentation on the photo montage. Paul?
Thank you, Judy. Are you all seeing my screen?
Yes.
Yeah. All right. Again, wasn't a lot of clear skies since last month, so I don't think there's a lot of new images, but I did have a handful or so in my email. It's just not going forward. Here we go. I included this one just because it's kind of neat and dear to a few members of our center who's been involved with the Deanery project, but this is a really cool project. Dave Chapman can probably speak to this later on if he wants or wants to say a few words about it. But We did have a few clear nights. I know up in the city on the coastline, you guys had more clear nights than I did in the valley. Mike Bosshot's still going at it, doing his great work through the windows of an apartment building. The sun's getting active. We've all seen probably posts about the sun and people out west and up north seeing auroras. So it's nice to see sunspots again. There's actually a new group coming around right now in the last couple of days. That's a larger group than what's on the sun for the last few days. So I think Dave Hoskins is still one of our busiest guys out there taking pictures. Any clear sky, he seems to be out there with his camera.
How long of an exposure was that, David?
About 20 seconds.
Just snuck out from behind the clouds.
Yeah. Actually, it wasn't a cloud. That's from, I think from a smokestack at St. Mary's.
Oh, wow.
There was a big, I mean, it was like -30 that morning. So.
That's a nice one, Paul.
Thank you. I'm not entirely happy with the processing yet, but taking the one night I had, that's what I got. David obviously found some clear skies a couple nights in the dark. He's got some decent blue sky shots here.
Yeah, we were lucky here too. I think we had 3 clear nights, and 2 of them my dome was frozen shut, so I ended up using my camera instead.
The Guinean's chain.
Nice.
I love the Virgo cluster.
It's sideways.
That's it. Like I said, not much this month. It's been winter and bad weather seems to do that to us.
The way February's starting, it won't be much better for next time.
Yeah, well, we can always hope.
I actually had one clear night here a couple nights ago. I had a clear night and I thought it was going to be beautiful. It was one of those nights that just looked perfect. The seeing was good. And just I went down to the observatory and I looked across the backyard. And I'm like, why is everything so bright? And there was just like a low level frost hanging around. And if I came up and stood on my deck, the sky seemed more transparent. But if I was that 10 feet down on the deck and another 20 feet down in elevation in the backyard, it just seemed there's frost hanging around. And where I can only do anywhere between 5 and 7 minute exposures before reaching the sky background, I could only shoot for 4. And I was totally fogging out my images under a moonless sky, which is just so weird.
Yeah, we had the similar experience too here.
Yeah, it was like I was shooting under light pollution.
Yeah, I've got shots actually of some light pillars, ice, the ice pillars I've never seen before around here. And
yeah, it was -20 and the dew point was -21. Humidity was 80%. It's just unreal. Anyway,
There you go.
nice.
That's it for me today. Thank you.
Thanks, Paul, so much for that. I'm sure that hopefully, fingers crossed, the weather improves with clearer skies, and come the March meeting, we'll have some more incredible shots from our members. And I also like to invite the Astro Sketchers as well to submit some sketches that they've been doing over the month. So please do so. The next item up on our agenda is our keynote presenter, Dr. Jennifer West. Mary Lou Whitehorn was supposed to introduce you, Jennifer, but thankfully we had the wherewithal a while back and Mary Lou sent me her introduction that she wanted to give to you. Should something happen that she can't come? Well, she was here, but her power went out, so bear with me. So, like Mary Lou, it is my privilege as well and pleasure to introduce you to Dr. Jennifer West. She's the research associate at the University of Toronto and Dunlap Institute for Astronomy and Astrophysics. Some of you have known Jennifer for quite a while. Paul or Dave Lane, you mentioned you had known Jennifer for a while, and Mary Lou has known her since 2000 at the GA in Winnipeg, which is where you are now. Not the GA, but at least Winnipeg. She was an undergrad at the time and had only recently joined the RASC. Jennifer went on to achieve her PhD from U of Manitoba in 2016, after which she joined the Dunlap Institute. Her research goals are to understand the origin of magnetism in galaxies and how it influences galaxy evolution. She's an expert in radio polarimetry and cosmic magnetism, and she uses radio surveys and radio polarimetry to study magnetic fields in supernova remnants and in the Milky Way Galaxy. So she uses a combination of radio observations and modeling and is focused on discovering the 3D geometry of the Milky Way magnetic field, as well as understanding the fundamental nature of magnetism in galaxies, with the ultimate goal of determining the structure and origin of magnetic fields in the Milky Way, in other galaxies, and across the universe. Jennifer also works on large radio surveys with the Canadian Initiative for Radio Astronomy Data Analysis to produce science-ready public data products for surveys such as the Polarization Sky Survey of the Universe's Magnetism, or the acronym POSSUM. And this project uses the Australian Square Kilometre Array Pathfinder. She also enthusiastically embraces astronomy education and outreach. So not just a pure scientist, she's a recipient of the International Dark Sky Association's Dark Sky Defender Award in 2011. She's received RASC's Ken Chilton Prize in 2010 for contributions to astronomy and education outreach. And she has certainly led astronomy-themed wilderness canoe trips hosted by Nature Manitoba. So she has many varied interests, including gardening, growing and cooking her own food, and I love this one, dancing, hiking, canoeing, and being outdoors under the stars, and astrophotography. So without further ado, I'd like to welcome Dr. Jennifer West to our meeting. Hello, Jennifer.
Hello, thank you very much. And let me get my... All right, so I'm really happy to be here today, and a little bit sad that I can't join you in person, but I guess the wonders of Zoom lets me join from afar. And so yeah, so today I want to tell you a little bit about some of the work that I do, and some that you heard about in that introduction. I had some recent work that received a fair amount of press coverage, and so that's the story that I want to tell you about today. And this is about the Galactic Tunnel in the sky. And so in the media, there were some interesting interpretations of this story, and so I'd like to give you sort of the inside. Hello?
Yes, we're here.
Oh, sorry, I heard someone say hello. So I'd like to give you a bit of the inside story, if you will, and tell you a little bit about the background and how this project came to be. Okay, so I always like to start with something familiar, and I think in this crowd especially, I think most of you have been fortunate enough to be in a dark sky where you can see the Milky Way stretching across the sky. And so in a lot of ways, the work I'm going to tell you about today is understanding the geography, if you will, of our galaxy. I think it's easy to look up in the sky and we see this somewhat familiar picture if you're someone who goes and looks out at the stars a lot, but it's sometimes easy to forget the the number of, the three-dimensional nature of space, and how the objects that we see are at vastly different distances. And I think it's something that some of us know, and I know this very well, but it's still hard to really grasp how three-dimensional space is, and how far away some things are, and how close things are in a relative sense. So it's hard to get this true three-dimensional picture. And that's something I spend a lot of time thinking about. And we're inside the Milky Way Galaxy, and so we see it in every direction. And so if you want to take a photo like this from Earth, you have to go to the southern hemisphere and also the northern hemisphere, and stitch together pictures across the whole sky. And unless you go to space or the North Pole, where you can do it, but still you can't take it in one night. You have to stitch pictures together over the course of the year. So the sky in every direction is the Milky Way Galaxy. And in a picture like this, we also have other galaxies. And some of you maybe recognize some of these other galaxies. There's one up here, which is the Andromeda Galaxy, which many of you have probably seen. There's also the Large and Small Magellanic Clouds down here. And so those are other galaxies, and those are much, much, much farther away. And in this image, there's millions, billions of other galaxies as well, that we need a telescope to be able to see them. We can reveal a certain number of them with a backyard telescope, and some of them require many, many hours of observing with the largest telescopes on Earth. And we also have stars at a huge number of different distances. So as I mentioned, I want to talk a little bit about geography. And so if we look at a map of the Earth, we divide the map into, we have the equator, and we have the North and South Pole of the Earth. And often when we show a map of the Earth, we show it in this kind of orientation and this projection. We show the equator in the middle. And similarly with our galaxy, we have the galactic plane, which is our galactic equator, and we have north and south galactic poles. And usually when we show a picture of the galaxy, especially astronomers like to show it in this kind of configuration with the galactic center in the middle of the picture. And of course, like our picture of the Earth, it kind of distorts our view of what we see, and it can distort how we think about the geography of our galaxy when we're always seeing it in the same view. And so the work I've done challenged that a little bit, and I'll show you a little bit later some other pictures in other orientations, which I think change the way we look at things. Now, the other thing about this picture is this is what we see with an optical telescope, or this is what we would see with our eyes if we could see very faint things. But I'm a radio astronomer, and so I look at the sky with radio telescopes, and the sky looks quite different. There's similarities, of course, but there's also significant differences. And this particular telescope, this is the 26-meter John Galt telescope at the Dominion Radio Astrophysical Observatory in Penticton, British Columbia. And this telescope was actually used to take the images that I'll show you a bit later on that helped me make this discovery. So this image is a radio image. This is actually quite an old radio image. The sky was first observed in radio waves in the 1960s. And so when we see a picture like this is the same orientation that we saw, that familiar optical picture with the galactic equator or the galactic plane through the middle. The galactic center here, where it's really bright, is in the middle, and then we have our galactic poles. And one of the things that's really striking in radio waves is this huge thing, this arc that extends over the top of the galactic center. And so this feature is called the North Polar Spur. And as I said, the first radio maps were made in the 1960s, and that was when we first discovered this North Polar Spur. And along with the North Polar Spur, there's other features that have been identified over the years, and I just labeled them as other loops and spurs, as they're often referred to in the literature. And there's this other thing over here, which is called the fan region, which is more or less just a spot in the galactic plane, but it's kind of a bright spot that looks a little bit different. And in an image I'll show you later on, I'll show you why it was really noticed. In this picture, it's not really that noticeable. But this North Polar Spur, we saw in the 60s, and anyone who looks at radio astronomy maps, this is a very striking feature. And when I first saw a map of the sky and radio waves, it makes you wonder, what is that? And what's causing it? Where is it? And then the answer is that we don't really know. And the research that I've been working on is to try to answer this question. And I have an idea of what this is, and I have a model that explains this feature. And this model is just a model, though, and it tries to explain all the things that we see in the sky. So any good model has to explain all of your observations. And as soon as it doesn't explain some of the observations, well, that means the model failed and you need a new model. So far, this model seems to explain all of the things that we observe, and I'll tell you a little bit more about that. But I want to go back to this familiar optical picture. And one of the things that you might notice in this picture are all of these dark areas here, which many of you probably know is dust. It's cooler regions. And so there's stars behind that dust, but we're not able to see it because the dust is effectively blocking the light. And there's this area of dust right here, which is sort of around where the North Polar Spur is. But if you look in optical, you don't see anything. There's no evidence of this big arc across the galactic center other than this little splotch of dust. When we look at the sky in X-rays, it looks like this. So again, quite different from optical, and there's some similarities to the radio. In particular, we see this huge North Polar Spur in the X-rays. And we also see some X-ray light down below the galactic plane. So again, our galactic center is here. But you might notice that this black splotch that we see in the optical light is also showing up in the radio. So this dust is absorbing the optical light, but it's also blocking the X-rays. And so whatever is causing this bright X-ray light, it has to be behind this splotch of dust. And so this piece of evidence here, along with the North Polar Spur's position in the galaxy, so it's extending over the galactic center. And that have led a lot of astronomers to believe that this X-ray emission and the North Polar Spur has something to do with the center of our galaxy, with the maybe some kind of outflows from the central black hole that's in the middle of our galaxy. And if we look at the sky in gamma rays, which is even higher energy light, we see these two lobes of emission that seem to come out from the galactic center. And if you put together a combination of X-rays and gamma rays, this X-ray, which is the blue, seems to form some kind of an envelope around these lobes of gamma ray emission. And so this is a really tantalizing picture to say that this North Polar Spur has something to do with our galactic center. And it reminds us a little bit of pictures of other galaxies. And this is another galaxy with radio emission as well. So the orange that you see in this image is from radio waves. And we see this kind of outflow or jets that come from the central black holes of galaxies. We call these active galactic nuclei. And so is this picture that we're seeing in our Milky Way galaxy evidence of an active galactic nucleus? Are we seeing big outflows from the center of our galaxy? And so that is one picture that in particular, astronomers who study X-rays and gamma rays think that the North Polar Spur is some kind of evidence of jets from our galactic center. And as I mentioned, this dust, which shows up in the X-rays, is something called the Aquila Rift. It's an object that we have identified. And so the picture that the X-ray astronomers have looks something like this, where you have us here and the sun, and there's this big dust emission here, which is the Aquila Rift. And behind that is the North Polar Spur, which sticks up from the plane of our galaxy, up above the plane, and goes and loops over the galactic center. So this is the picture that the X-ray astronomers have. And it's a model, and it explains some of the observations, and it, as I said, that picture that it's arcing over the galactic center is really compelling, but there's a lot of other evidence that contradicts this picture. And so I want to go back to the radio picture, and most radio astronomers disagree that this object is actually part of the galactic center. And so I want to give you the other side of the coin, if you will, and give you some of the evidence that says, no, this object is actually not at the galactic center, but it's much closer to us, and it's much more nearby in our galactic geography. And so there are other kinds of light that we can look at in the sky. And so I've talked about what we see with optical, with our eyes, and I talked about what we see with radio, but there's also what we see with dust. And dust is generally observed with infrared or microwaves. And so this is a dust map. And in this dust map, if you look closely, you can see some emission here, some dust that looks like it's more coincident with the North Polar Spur. There's also this dust here, which we can see in that optical picture and in the X-ray picture. And this is that object that I called the Aquila Rift. But there's also this dust here that looks like it's part of the North Polar Spur. And over here, where I pointed out this object called the fan region, there's also a whole lot of dust over there. So this is dust. We can also look at gas, which is cold. And this is often observed also in radio, but at a different radio wavelength, where we see hydrogen gas. So this is cold hydrogen gas. And if you compare these two pictures, the dust and the cold hydrogen gas, they look quite similar. And again, you can see that there is some cold hydrogen gas, which is coincident with the North Polar Spur, and also with the fan region and the Aquila Rift. So we have dust and gas that are associated with these features that we can identify. But the really interesting thing about dust is it gives us a way of measuring distances. So as I mentioned at the beginning, when we look up at the sky, we see all of these things compressed in our three-dimensional world onto this two-dimensional surface. And it's really, really difficult and challenging in astronomy to be able to know what distance things are at. And so finding ways and clever ways to measure distances is something that astronomers are always trying to do. And so how do we use dust to measure distances? Well, it comes back to stars, and it comes back to this map that I showed at the very beginning. So this map is actually not a photograph, which you can take, if you go out into a dark sky and point your camera, you can take a photograph or an image that looks similar to this. But this particular image is something that was created with the Gaia satellite. And Gaia observed individual stars and measured very carefully the brightness of individual stars. So this is actually a map that is made from observing individual stars in the sky. And from those individual stars, Gaia can actually measure distances using parallax. So some of you have probably encountered the idea of measuring distances with parallax before. If you hold your finger in front of your face and you close one eye then the other, you see your finger shifts with respect to stuff in the background. And this is what happens when we where the Earth goes around the sun, and that distance as it goes around the sun changes the star's position of a nearby star with respect to stars that are much farther away. And by measuring that change in position, we can very accurately measure the distance. And so we've done this before for a long time in astronomy, but this Gaia satellite has really revolutionized the number of stars to which we've measured parallax. And so this is a little infographic that shows the number of stars that Gaia has made measurements on. And in particular, we have parallax measurements for over 1 billion stars. So that means we have very good distances for over 1 billion stars. And from the measurement of the star, we can not only get the distance, but we can also tell how much dust is between us and that star. And so by knowing the distance to the star, and we know how much dust is in between us and that star, we can make a very accurate three-dimensional map of dust in our local galaxy. And so that's what I'm showing you here is a fly around this map of dust that was made by measuring stars. And so all these little clumps are showing you individual little clumps of dust. And this is a map where the size of this cube is 1,000 light years on an edge. And so let's come back to our galaxy. And if we look at a top-down view of our Milky Way Galaxy, our galaxy is about 100,000 light years across. And so 1,000 light years here is us, here's the sun, out about 25,000 light years from the galactic center. And 1,000 light years around the sun is this little green box here. So that dust map I showed you is the dust in an area in this little green box. And so we know the distance to this dust, but it's within a very close by area. But if I go back to this map, we see that there's dust associated with the North Polar Spur. And so from this technique of being able to measure the distance to the dust, we actually know that the distance to the dust up here is much, much closer than the galactic center. So if I go back to the map, the galactic center is way over here. And we're not measuring out that far, and yet we're seeing this dust associated with the North Polar Spur. And so from this measurement, we actually know that this dust here is much closer to us. And so this is one piece of evidence that this North Polar Spur actually isn't at the galactic center, but it's actually something much more nearby. And this isn't the only piece of evidence. So there is more evidence. And this is more where my part of this picture comes in, or the work that I've done comes in. And this is in understanding magnetic fields. So I need to talk a little bit about magnetic fields and about how we can investigate them and how we can understand them. So when I say to you a magnetic field or a magnet, maybe the picture that you think of might be this one. This is something that I think most of us have done at some point in our lives, is in school maybe, where we take a bar magnet, something that you stick on your fridge. And if you scatter iron filings, so little pieces of iron over top of a piece of paper where you have a magnet underneath, they organize themselves into this pattern. And this is revealing the magnetic field of this magnet. So it's creating forces that are moving those pieces of iron around, and they're aligning themselves they're organizing themselves that reflects the magnetic field of the magnet. We've also, I think, heard about magnetic fields sometimes when we talk about the sun, and when we talk about aurora and seeing northern lights on Earth. This is due to our magnetic field and our sun's magnetic field. And I really like this picture. This is an actual animation of a solar flare on the sun, and you can actually see these lines. And this is charged particles on the sun that are tracing the magnetic field lines, much like the iron filings traced the pattern of the bar magnet. So how do we measure these magnetic fields? Well, we can use radio waves, and we use something called polarization. And so polarization is a way that the light is aligned. If the light is all aligned in the same direction, we say that it's polarized. So light is a wave, and it can have all different kinds of orientations. But if it's all in the same orientation, then we say the light is polarized. And in this picture here, we have light that's coming from a source that's not polarized. It's all scrambled and all different orientations. And we can put a filter in place, and we can let through only light that has a particular orientation. And that is, in effect, polarizing the light. And so the same kind of thing happens in space. If we have a star, and that star is emitting light that is unpolarized, and it's passing through some region in space which has a magnetic field, there's little grains of dust that are in that region of space, and those grains of dust happen to align themselves with the magnetic field, much the same way like the iron filings did. And then the light that comes out the other side is polarized, and so it acts like a polarizing filter. And then we can observe this light with a telescope, and we can take that set of observations and make a map that looks something like this. And so this is a map of the magnetic field lines in our galaxy due to dust, which is very similar in concept to looking at the way iron filings organize themselves on a piece of paper. But once again, we don't have any distance. So we need to, again, find a way to tell where things are in space and how to tell the distances to various things. But if you look closely here, once again, we can see emission that's from the North Polar Spur. So this is dust, and dust can be polarized. It turns out that charged particles in space also emit light, and those also get polarized. So the charged particles themselves are spiraling in the magnetic field and emitting light, and they emit radio waves. And so this is another kind of polarized light, but it's the same idea. And we can make a map that looks like this one. And so these two maps, this one's from dust and this one's from radio polarized light from charged particles. They look similar, but they're not exactly the same. So they're similar, but a little bit different. And what we can do is compare these two maps, and where they're really similar, we know that the polarized light is coming from the same place. And so once again, here we have the North Polar Spur stretching up above the galactic plane, and it has a very similar kind of shape and orientation to the dust. But that's not quite good enough. We need to do more comparisons. So how can we get distances? Well, we can go back to stars and we can look at the way the starlight is actually polarized, and we can compare it to the dust. And remember, we know the distances to the stars. So where the stars line up with the background, we know the distance to the stuff in the background. And if the stars are not lining up with the background, then we have an indication that the stars are in a different location from either the dust or the charged particles. So here is a map. This is the North Polar Spur. This is a zoomed in version. So I don't know if you can kind of see the North Polar Spur here. And in this map, we're showing the little red lines are coming from the charged particles, and the little yellow lines are coming from stars. So where they line up, we know that the charged particles and the stars are at the same location. So in this part of the sky, we see that the two are kind of aligned and the stars are nearby. So this tells us that the stuff from the North Polar Spur is actually nearby. But if we look at this bottom part of the North Polar Spur, this is the part that's close to the galactic plane, you might notice that the red and the yellow don't line up. So they're actually quite different down here. And this is telling us that they're not aligned. And so the stars and the charged particles have to be at different distances. And this tells us that the charged particles are more distant because the stars are nearby. So let's go back to this picture. And as I said, this is where my part of the story comes in at last. So we have this picture from the X-ray astronomers that there's this dust cloud and this North Polar Spur is behind it, which has to be true. But this part, which is the upper part of the North Polar Spur, other observations are telling us that it's nearby. So what kind of a picture could we have that would make this part nearby and this part still far away? And I think the key here is to remember that we're living in a three-dimensional universe. So if you take this line and you tilt it down towards us, it actually means that this part can be behind this dust cloud, and this part can still be nearby, just over our heads, if you will. So there's that idea. So let's go back to this radio map. And I spent a lot of time telling you about polarized, looking at where the polarized light is. This radio map is not polarized. So if we want to look at polarized radio light, the map and the picture looks quite different. It actually looks like this. Now we're just seeing this part of the North Polar Spur and this thing, which I pointed out earlier, which I called the fan region. So if we go back to this map, the fan region doesn't really stick out. But if we look at it in polarized light, suddenly the fan region sticks out because it's polarized, whereas the other part through this center of our galactic plane is not. And one of the reasons is that this light must be coming from something that's nearby, because the middle of the galaxy is still polarized, but it's kind of like when we see the dust causing dark splotches in the optical light. We don't see it because it gets blocked. Well, we don't see polarized light from the middle of our galaxy because it gets scrambled along the way. It gets unpolarized as it travels to us that long distance. So the only light that makes it to us is stuff that's nearby. So we have these two blotches of really polarized light that we think should be nearby. Now, another thing is coming back to this map of the Earth. And remember at the very beginning, I told you we often look at the Earth with our center point in the middle. It's always the same center point. It's always the galactic center, and in the Earth, it's always the 0, 0 point in our coordinate system. And I was at a conference and somebody mentioned this idea how Antarctica is all stretched out at the bottom of the map. And if you look at the polarized light, we also have an Antarctica here. And so the stuff that's down here isn't really stretched out the way it looks like on the map. Just like if we shift the point on the Earth, we see that Antarctica is much smaller. So if we do the same thing on our view of the sky, what I did was take a point in between the North Polar Spur and the fan region and thought, what does the sky look like if we look at it instead of this normal view with the galactic center in the middle, but if we look at it with a point here in the middle of our map. And when I do that, we get a picture that looks like this. Suddenly the picture looks kind of different. And the lines, these are the magnetic field lines that are tracing the North Polar Spur, and the lines that are tracing the fan region, they almost look parallel in this view. And so that started me thinking about our picture and whether our picture was wrong, or whether this picture was biasing our view of what was really going on in the three-dimensional sky. So while I was thinking about that, this was a couple of years ago, there was another old paper that I came across. And in that paper, they mentioned that the North Polar Spur and the fan region might be features of the local arm of our galaxy. And in the map of our galaxy, this here is called the local arm. So this is a spiral arm of our galaxy, and this is where our sun is located. And this local arm has an orientation of about 70 degrees. If we consider pointing towards the galactic center as 0, then it's about 70 degrees following along the local arm. So I made a model where I made a very, very simple scenario where we have lines that are oriented along the local arm. So once again, this orientation here. So I had lines that are going along this local arm. And then this is a top-down picture. So you have to put your three-dimensional brain on and think about, we are in the middle here. And if you think, looking over your head and you see 3 lines going overhead, kind of like if 3 airplanes flew overhead and left contrails. And then we have 3 lines below us. And if you look to your left and you look to your right, you have 2 lines going along either side of you. What would that look like if those were going in space and we were surrounded by these lines? What would that look like? And it turns out it looks like this. So it looks like these lines, we have one beside us, and I'm only showing 4 lines here, but we have 2 that are over our head, 1 below our feet, and 1 is beside us. And this looks sort of like what we see with the fan region and the North Polar Spur. And it turns out if we orient these a little bit differently, we shift them, we get something that even more resembles what we see in the actual sky. They're not quite the same though. This model is still not quite reproducing what's going on down here below. So I found that if I took those lines and instead of having them straight, I made them slightly curved, then we get a picture where the bright stuff from those lines is causing bright streaks in the sky in these locations, which correspond pretty closely to the location of the North Polar Spur and the fan region and these other things that I labeled other loops and spurs. So if we come back to our picture of the galaxy and our position, the red dot is us, the sun, and we have this little box with these magnetic filaments. And once again, this is a top-down view. So some of these filaments, they're not all aligned. If we looked from the side, they would be some of them higher and some of them lower. And I'll show you a three-dimensional picture in a minute. So the lines are actually about 1,000 light years long. And these little pink stuff that you see in this image is actually a two-dimensional view of that dust cloud. So I showed, let me go back to the three-dimensional dust cloud. This animation here, if we compress it into 2 dimensions and project it onto the plane of the galaxy, then what we get are these pink clouds here. And so one of them, this one here, is that cloud that I called the Aquila Rift. And if you see the North Polar Spur, which is this line right here, it's actually behind the Aquila Rift. So there was this evidence that the one part of it had to be far away while the other part was nearby. And so this model is able to resolve that contradiction and explain that how one part of the North Polar Spur can actually be far away and the other part can actually be quite nearby. And suddenly the whole picture makes sense and the evidence is all consistent. So the picture from X-rays and the picture from radio astronomy suddenly make sense together as one picture. And it turns out there's also another interesting point. This little pale yellow patch in the middle here that's labeled the local bubble is a void around our sun where we've had, we think that this void was caused by a number of explosions, supernova explosions. And it turns out the direction to the supernova explosions is in this direction. And these lines are bent kind of around them. So if you imagine an explosion happening here, they would bend the gas behind it and it would bend in this direction as well. Now there's one last point that I want to make, and this is to go back to this fan region and explain why it's called the fan region, because it doesn't really look like a fan. And the fan name actually came from very old observations, where this was the observations from 1963 or 1964. And you can see that this little shape here, this is the orientation of the polarization. So like the iron filings on the piece of paper, if you shook them over the fan region, they would go into this shape, which kind of looks like a fan. It's fanned out. And it turns out that we can also explain this picture with this model. because if we have a magnetic field that's going along the line here, we have the sun here. And if you imagine what this line would look like if you're here at the sun, if you're looking from this side, it looks like the line is coming towards you. And if you're on this side, it looks like the line is going away from you. And there's this property called Faraday rotation, which means that the wave actually gets rotated in a direction depending on which way the magnetic field is going. So if we're looking on this side, the vectors get bent one way, and if we're on this side, the vectors might get bent the other way, and we get a fan shape. So this is actually what happens to the magnetic field vectors, as if we're looking at a magnetic field that's going by us. Like it's like the Doppler shift. If you think of an ambulance driving by you while it's blaring its siren, the sound changes as it goes by you. And so this appearance of these magnetic field lines change as they go by us. So this model is able to explain all of these little different pieces of evidence and build this picture that this is actually what our these magnetized filaments in our local neighborhood look like. So if you look from the top down, they look like those little lines. But if we look from the side, you can see that this one is, the green one is the North Polar Spur, and it's above the galactic plane. This one is below the galactic plane, and this purple one is in the galactic plane. And so this is where the tunnel came from, the magnetic tunnel that got that was in the media, because this picture to me reminded me, if you were to have a curving tunnel and you were to draw lines on that curving tunnel, it would look like this. So I found this picture of this curving tunnel and drew the lines. And then when I took the picture of our galaxy and also put it in that projection, suddenly it surprised even me, this picture, and it was very, very compelling. So this is close to where I'm going to end. I just wanted to leave you with this picture of this magnetic tunnel, and from the wondrous technology that we now have, I can put the stars and the the constellation outlines on here. So if you go outside, and if we had magnetic eyes that could see the magnetic field lines and this polarized radial light, this magnetic tunnel would be all around us. We would be able to see it in every direction in the sky. So this is the fan region, which is going along the galactic plane. So if you see the galactic plane and these, familiar Cassiopeia and Cepheus, you can imagine that's one end of your tunnel. And then the North Polar Spur goes up here through Corona Borealis and through, I'm blanking, the constellation Boötes. It's written right there. I kept thinking Arcturus. Anyways, so it goes across the top of your sky. So this is basically looking up at the zenith. So this is Vega here. And then the other part of the tunnel is coming up from the southern horizon. So this is obviously going to vary what time of year, but this is if you're looking at the sky, in the fall, in the evening from almost anywhere in Canada, this magnetic tunnel, you can imagine you're going down the arm of our local arm of our galaxy, you're looking down the barrel of that arm, which I think is pretty cool. And that I'm going to stop. So I'm happy to take questions.
Jennifer, James here.
Yes.
How do we resolve the North Polar Spur with the lobes that we see in the infrared image?
Yeah, so I think
like are some of those parts of the lobe close to us and some are further away, but are they centered on the galactic center?
Are you talking about this image?
That's one of them, yeah.
Yeah.
You see
Yeah.
those big lobes up above and below the plane.
Right. Yes, exactly. Right. So yeah, that is a great question, and that's something that we still, so that this model doesn't fully explain what these lobes are, but it is possible that we have more than one thing going on here because we have this three-dimensional view. So it's possible that some of this emission is associated with the galactic center, but that this actual North Polar Spur emission, I'm 99% sure that this is not associated with the galactic center because we just have too much evidence to show that it's local. From the dust and the starlight polarization, there's all kinds of very independent observations that show that this emission is local. This red emission may not be local. And it may just be a coincidence that the blue and the red line up in such a compelling way. Or some of the blue might actually also be distant. So there could be, multiple things going on here. And it's just, it's somewhat an unfortunate coincidence, I guess, that it's very hard for, I think, us to separate the two. And to maybe believe that it's a coincidence, but like I said, there's just so much evidence that this is local that I don't think it can be. The more I stare at this, I also notice that this isn't quite centered on the red, right? Like it's twisted, and so it might just be our human brain wanting to make this a coherent picture when it really isn't one. Sense.
Jennifer, Larry Bogan here.
Hi.
Hi. What we're seeing, you draw these lines, but this is material along magnetic lines. And is the material concentrated? And I mean, magnetic lines are not individual lines, but they are gradients throughout space.
Right.
And so somehow there had to be more material in certain areas than other areas in order to create this loop, or whatever you want to call it, or the tunnel. And is there any theories as to why we have this appearance rather than a solid map of material along magnetic lines?
Yeah. So this sort of what I was alluding to, I'm trying to find the slide, when I had the direction to the supernova explosions. So if you are familiar with images of some supernova remnants, like the Veil Nebula, there's a lot of examples of supernova remnants. You'll notice that they have a kind of filamentary ropey appearance, especially in optical. And so that's what these filaments are. That's what I think they are. I think they are basically remnants from supernova explosions, but not necessarily one single supernova remnant, but the remnants from multiple supernova explosions that occurred when it created this local bubble. And so you're exactly right. What happens in a supernova explosion is that there's a shock wave that is ejected into space, and it plows up the interstellar dust and gas, and it piles it up in a shock front. And then that shock front over time dissipates. It also elongates along the magnetic field. And so what we get is polarimetry structures that are elongating along the magnetic field lines. At least that's the picture that is presented in this model.
Thanks.
So I have a question about what the JWST might do for your research.
Yeah, so I mean, JWST is going to, so the research that I've been talking about here is really large scale. So this is like the entire sky, right? So the image here is the entire sky. So what JWST is going to be looking at very small individual objects. And so this will certainly shape our ideas around, you know, star formation, and JWST is not going to directly be able to probe magnetic fields, but certainly in combination with other data, that's, you know, astronomy is I think in growing, it's the amount of data that we have now is massive, and we're starting to appreciate the need to pull different data all together and to understand the picture as one. Sort of like this example where the X-ray community was really advocating for the North Polar Spur to be a galactic center object, and the radio community it's local. And so something has to, you know, bring those communities together, and they have to start talking to each other. And I think that's happening with increasing frequency. So certainly what we learn from JWST will influence our picture of what's going on in our local neighborhood for sure. But it's not going to make an all sky image.
Hi, Jennifer, it's Mary Lou.
Hi.
I'm sorry, I lost 20 or 25 minutes there when the power just went out.
Yeah.
And so this has been wonderful, what I've heard of it, what I've seen of it. I'm fascinated, and I have a double-barreled question, I'm sorry. This structure appears to be there, this magnetic structure, and I'm assuming that the sun's position is it's just randomly there. It has nothing to do with, it's not like the solar system is moving through a magnetic tunnel and being constrained in its motion as it orbits the galaxy. I'm assuming this is just a random alignment. And then the other thing that popped into my, aging brain is a few days ago, I was just trolling through the Gaia data because it's just so amazing. And there is this mention that the sun is surfing along on a wave of gas, a 9,000 light year long wave of gas that undulates, and the sun is surfing, it's kind of dives through and comes up and down again. And is any of this related?
Yeah, so I mean, it's sort of related. Okay, so let me address the first point about our position in the sun, and I don't know what you may have heard or not of, but if our sun is located here in our galaxy, and this is our local arm. So the model that I have orients, the original model oriented these magnetic filaments along our local arm. So that in a sense is then the tunnel, if you will. It's the local arm and the magnetic field lines that are running along the local arm. And we know this from other galaxies as well. We know that galaxies have these magnetic fields that sort of follow the pattern of the spiral arms. And so this is a reasonable assumption. What we don't know is why, what is actually maintaining this magnetic field and what's causing it. And that's what this idea that I was mentioning with this shock fronts from supernova explosions. So I don't know if that addresses your point, but that's sort of like what this idea of the magnetic tunnel is all about. It's the local arm. And this wave of gas that you were referring to, that's been also in the news a little bit, is very related. So it's related to these dust clouds that are here and here. Did you, Mary Lou, did you see the 3-dimensional dust movie that I played? I can play it again here. So that wave of dust is found by a technique that was used to make this 3-dimensional movie. And so it's related in the sense that these are dust clouds that are piled up at the edge of what we call the local bubble. And then I think these magnetic filaments are also related to the processes that went to creating the local bubble. So that wave that they talk about is the dense molecular gas. And so I'm talking about different kind of gas, which is much more energetic, and the synchrotron emitting component, which is like where the electrons are moving the fastest. So they're related, but they're not exactly the same thing, if that makes sense.
Thank you, Jennifer. I'll thank you on behalf of Mary Lou. I just got a text from her. Suffice to say that she said, power gone again.
Oh no.
So she missed the latter part of your explanation, but because this is being recorded, she will hear your reply.
Perfect.
Okay. Pat, are there any questions in the Q&A that we need to make note of?
Paul Gray and Paul Heath both have their hands up.
Okay, we'll answer those two, and then we'll bring it to a closure. Thank you.
Hello, Jennifer. It's Paul Heath. I'm just wondering if you compared that map you showed of the magnetic fields looking like a tunnel with a fluid dynamic picture of water passing through a hose. And why I say they look very similar to me, of the fluid dynamic picture. And I would be interested to know if that would have some indication of maybe the speed of the particle movement. So would you be able to determine if they're actually moving in a tunnel formation, like moving in a direction at a certain rate based on the flow pattern?
I don't. I mean, I think they're have some similarities in concept, but they're not exactly the same that's being discussed there. So I don't think we can't directly apply that and directly calculate the speed. Also, so kinds of magnetic shocks are thought to accelerate the charged particles, electrons, but it's that acceleration is more complicated than just going along the length of the tunnel, if that makes sense. Yeah, it's a little, it's different than the fluid dynamic picture for sure. But I think, yeah, there's an analogous comparison that you can make.
Yeah, it looks very similar. That's why I wondered if there was a way to determine the speed of those particles in the tunnel formation.
Yeah, there's ways to find the speed of the particles, but they're not moving along the tunnel in that sense.
Okay, Paul Gray, last question for the session.
Thanks, Judy. Hi, Jennifer. It's been a while. Great work. It's been really amazing. The one question I have, what's next? Where do you go from here? Are you following this up with different wavelengths? What are other parts of the spectrum? What's the plan?
Yeah, so I mean, there's lots of different projects I have on the go right now. You know, it's sort of coming out this idea. The idea that I'm really exploring is what is responsible for maintaining this magnetic field in our galaxy that has an order to it. So that, you know, why would we have a magnetic field that's all aligned? So I'm looking at individual objects. So I study supernova remnants in in the context of how they're connected to the galaxy and what happens to the gas when a supernova explodes, and how does that gas get influenced by the galaxy. And another thing other projects I'm involved with are modeling the three-dimensional large-scale magnetic field of the Milky Way Galaxy. And when we have a picture like this, we use this as input to our model to model the whole galaxy. But as we've just pointed out, that there's so many features in here that are much more nearby than, you know, they're very close to us. And so if we want to measure the whole galaxy, we have to take the nearby features into account in our model in a different way. So we have to model them separately and then kind of add the nearby stuff to the large scale stuff. And so that's one of the things I'm working on, as well as making a complete model that takes into account local structures.
Cool.
Thank you. Jennifer, I'd like to thank you on behalf of the Center for an incredible presentation. The science you presented is rather interesting in terms of you're taking research done from various fields and putting them together in a collaborative effort as only a Canadian scientist could do. So I thank you for that, and thank you so much for joining us today.
My pleasure. Thanks for having me.
Okay, you're welcome to stay with us if you wish, and certainly stay for the Astro Chat at the end, because I'm sure people might have some additional questions that they're thinking about during the rest of the meeting that might want to ask you. So if you can stay, wonderful.
Yeah, sure. I'll stick around for a little while.
Okay, thank you. Okay, next up on our agenda is our second speaker, Tim Doucette, and he's going to give us a review of the Celestron Starsense Explorer telescope and the adjuncts. And what I had to chuckle was when I was in the process of emailing out the announcement to the members about reminder of meeting, that this particular product came out in my email from Celestron saying now available. So Tim, what can you say about this piece of equipment that people can now access if they so choose based on your review?
Yeah, so let me give you a little demonstration and a little bit of an explanation as to what I have found. So just a little bit of background. Celestron came out with this technology called the Starsense Explorer telescope line back in 2019, 2020. And the thing is that it's basically a cell phone app that you install as part of your telescope that gives you several different abilities to locate things in the sky. So we have a whole lineup of these telescopes. And what caught my attention was the fact that this was essentially turning a telescope into a push-to type telescope without having to have any motors or other technology besides your phone. You can see here from their website, they have a number of different models. Now, I chose the least expensive model for a number of reasons. Well, I actually bought two of them before Christmas. One I gave away as a door prize for our little Yarmouth Star Party. And the other one I kept for myself, and I'll explain why. But my agenda was slightly different when I first looked at this telescope, but then I started playing with it. And I found it quite interesting. So this one here is the one I have, is the Starsense Explorer LT. It's an 80 millimeter azimuth telescope. So I purchased the lens telescope just again because it was its cheapest at the time, but there's a few things that are good to note about this telescope. So looking at just some of the specifications that they have here, it's about a 900 millimeter focal length f11, so the standard kind of thing. The good thing is I found that they didn't overmarket this telescope. You know, they didn't include stuff like a 3 times Barlow lens, which kind of makes it pointless because of the large, the small aperture of this 80mm telescope, you know, and they're not including like a 2mm eyepiece and advertising like, oh, 700 times power. So they've really kind of toned down and focused a little bit more on the marketing side of things. Now, more or less on the marketing of the new technology piece of it. So I'll give you kind of a little overview as to what this package includes. So, of course, the telescope comes with the standard instruction manuals, software with license keys to download the different software that you'll use with it. One thing that I found that was interesting is that the software that comes with it, you can only download it. You're only supposed to be able to download it once, install it once. But I actually installed the software on 2 phones using 2 different keys, and which was quite interesting. I assume they're going to probably push an update and stop that sort of behavior. The other thing that comes with it is a couple, oops, I don't know why this is doing this, but a couple of things that come with it, of course, is the Barlow lens, 2x Barlow 20mm eyepiece, and a 10mm eyepiece, and the 2x Barlow. Quality of lenses is very good for what it is. I'm just going to jump here to my next piece. So here's the telescope. I had it set up one night here. The tripod itself is, for this telescope, is adequate. It's not the telescope, the whole package. What's really nice about it, and for beginners, it weighs less than 10 pounds. So it's about 9 pounds with all the gear on it. It comes with a little red dot finder, which is actually kind of pointless, really, because once you've got this mechanism installed with your phone, which just slides in there, like you can see I've done, you slide your phone in there, you download the app called the Starsense Explorer. The red dot finder really doesn't do a whole lot. So what you do is, once you've got your phone in there, you can use these 2 little knobs to center the phone over top of the mirror that's aligned that's in the sort of the package here. You can see this little corner on the left. That's where the mirror is. Once you've done that, your phone goes into a setup mode, and you can see here the front of the telescope and a crosshairs. So what you do is you essentially line up an object, and my skies are so dark here that all I had to do was point it at my parents' window, so I could peep on them for a minute, and it lined it up. So once you look through your eyepiece, essentially what you want to do first, you look through the eyepiece, and so here's the window, and here's the little lamp there in the window, and then you just point your little pointy crosshair onto that target, and that lines up the phone with the camera of the camera phone and your eyepiece. You can see here, I don't know if you can see a little bit, there was a bright star there, that was Sirius, and Orion. I'm just using my phone to record. So then what you do is you point the telescope. It just tells you to point it at a spot in the sky. You give it a point, you point it up there, and with the magic of plate solving, the app on your phone takes pictures continuously, and will continuously take pictures of the night sky and plate solve it, and then tell you, hey, okay, now move your telescope in this direction to where you want to go. So I'm going to just do a quick demo of searching. We'll just search for Sirius, which we can actually see on the screen there, so it's not very far off. You can do a search with the app. It's got a ton of different objects. It tells you which ones are visible for your location, latitude, longitude. It's using GPS. It uses the gyroscope of your phone, and you can basically say, go take me there. It points an arrow to where you want to move. You just move your telescope, and get it, as you get closer to the object, you line it up as best you can. It will do another plate solve. It says, hold the telescope steady. So leave it alone. It does another plate solve. It gets you even closer to the target. And then you can use your slow alt azimuth knobs of the telescope. And once you've got it lined up in the crosshair, you look in the eyepiece and bang, the object is there. So it's a very, very awesome push-to telescope for a beginner. I did another test here. I was just testing out just to go to Orion, the Orion Nebula, just to see how well it worked. And I was getting, I tried it. I tried a whole bunch of targets that night, slewing around the sky, and it was bang on every time. I didn't have any issues. And so there now it says we're pointed, we're aligned it, look in the eyepiece, and you can see just very closely, very blurry kind of nebulosity there, but there's the trapezium and the Orion Nebula. And I think that's what impressed me the most. Now, for me, the idea was this little Millennium Falcon type piece of plastic is what's attached to the telescope. And my whole objective with this was actually to take this technology and put it on my 16-inch Dobsonian telescope. So in order for other people during our outreach events this summer in our astrotourism offering, is people that are coming to help me out may not be able to find things with the big telescope and in the night sky, and this is going to simplify it significantly for them. And so what I'm doing right now actually is I'm building a 3D model for my 16-inch Dob that will allow me to mount this this piece of hardware to my bigger telescope. So honestly, for people that are just really getting started, and I would say really this telescope is actually fairly well suited for somebody who's 8, 9, 10 even, who's just maybe just getting into astronomy, that needs something light and portable to be able to bring outside, and especially kids nowadays that are so used to using their cell phones, it's a perfect match. The other thing that a couple of little things, the little quirks, of course, is always quirks with these things. One of the things I wish they hadn't have done is they give you the eyepiece, the star diagonal that comes with it. Is a image erecting kind of diagonal, which is kind of good because that means you could use this scope in the daytime. But there is a little bit of light loss with the diagonal itself because it's got a prism of some sort in there to flip the image around. But other than that, it's a great little type telescope. Anybody that's going to be more kind of advanced, even like a 12-year-old, 10 or 12-year-old that's more advanced, I would definitely recommend the 130 millimeter reflector telescope. It'll make things a lot easier for, you'll be able to see a lot more essentially, even in a dark sky. And what's been cool about this setup is it's supposed to work really well, even in light polluted skies. It's depending on your phone and how well your cell phone, works at night. But on their website here, you can see there's a whole bunch of smartphone compatibility lists, and they really go back all the way to the iPhone 6, which is several years old. So I don't think you'd have a problem finding a good cell phone to use it with. So that's my little review of this little piece of hardware. If you have any questions, just fire them away.
One of the questions was, what was the name of this scope that you've just reviewed? Can you repeat the name of it, please?
Yes, the name of this particular scope was the Starsense Explorer LT80AZ.
Yeah.
The 80 millimeter. Yep.
Okay. Pat, were there some hands up for this one? Questions, folks?
No hands up.
Okay, so by the silence, I will take it that you explained it very well. Certainly, if people want clarification, they can contact Tim at the Deep Sky Eye through his website email there. But thank you so much, Tim, for that. Like I said, I had to chuckle when I was literally typing out the announcement for this meeting, and Celeste got an email from Celestron announcing this was now available. So,
Big Brother's listening.
yeah, I think so.
Well, the thing is about availability is before Christmas, I was trying to find this telescope essentially so I could give one away as part of our little virtual star party. And I was having a hard time finding one. And I found the company in Montreal, Lire la Nature, the astronomy store there. And he had just gotten a few in, and I asked him, I said, could I get 2 of them? He said, well, we're really only allowing 1 per customer. Oh, I said, yeah. I said, we had somebody call in and wanted 40 of them. And we decided, we knew he was just going to resell them. So we just decided to sort of sell 1 to everybody. And I said, well, I'm giving 1 away. I told him what I was doing. So he's like, oh, no problem. Then he said, I don't mind doing that then. But the price has gone up a little bit. It was $250 plus tax. And I think the price now has gone up to 3 something. So astronomy prices are definitely have gone up on everything, even used equipment. I put in an order for a new telescope mount before Christmas. And just because I knew it was going to be going up, the price went from $8,900 to about $1,300. So, yeah. Anyway.
You mean 13,000 or
Yeah.
1,300? Okay. What are you
13,000, sorry, 1,300. Yeah. Yeah, to 13,000. It was pretty crazy.
Which mount are you buying?
I've got the on order the Skywatcher EQ8RH Pro.
Okay.
And it's not going to be ready till December, at least.
Holy shit.
Yep.
Okay, well, thanks so much, Tim, for this. We look forward to future reviews too, I'm sure, because of the telescopes and your interest in equipment. Perhaps later on in the year as well, we can ask you if you have anything you'd like to talk to or
Sure.
talk about.
Anytime.
Great, thank you so much. We also invite other members, if they have equipment that they'd like to share their views on, just contact me and we'll add you to one of our meeting agendas. So please feel free to do that. Next up is Paul Heath. Paul is someone who is our outreach chair, but we also refer to him as our resident poet, because every month Paul has a new poem for us, and in a segment called Food for the Soul. So Paul, I will leave it to you. I'm assuming you have one.
Yeah, I'm going to try to screen share here. I don't know if it'll work. Does everybody see that?
Yes, sir.
Okay. Basically, as I've said before, I try to write the poem based on the topic, and there was so many things involved today. I figured I could just focus on one thing, and that was radio. So the radio telescope. So here we go. Ears see. Too dark, I cannot see. Squeak, squeak, chirp, chirp. Follow me. Tap, tap, clap, tap, tap. Too dark, I cannot see. Tap, tap, clap, clap. Follow me. Too dark, I cannot see. Tap, tap, listen. Surge and splash, follow me. Too deep, too dark, I cannot see. Oh yeah, oh yeah, oh yeah. Whales. Surge and splash, follow me. Too deep, too dark, I cannot see. Meow, yeah, oh, yeah, follow me. Too deep, too dark, I cannot see. Surge and splash, listen. Dark caves you now return. Tap, tap, listen. Deep waters you now return. Oh, yow, listen. The sky so murky I cannot see. Ping, ping, listen. Clouds hide the stars I cannot see. Stretch your ears, the sky is bright. Ping, ping, listen. The sky so murky I cannot see. Stretch your ears, the sky is bright. Ping, ping, listen. The sky is bright now, so much to see. Ping, ping, just listen. So we can see with our ears as well as our eyes. So I don't know how to unshare that. How do I? Okay, here we go. So hopefully that says a little bit about radio telescopes.
And I'm so glad you were here to read it, because you put the emphasis on the right syllable, which I could not have done had I had to read it.
Yeah.
Yeah. So that was wonderful. Thank you so much.
Thank you. As to, do you want me to talk about the outreach?
No, I'll ask for your input when I do my presentation on the news from the board, Paul. It's
Okay.
mentioned there, if that's okay with you.
Yep.
Okay, wonderful. Okay, next up is David Hoskin, and David is our observing chair, and he does a monthly thing called What's Up in the Night Skies. And so what's up for this month, David?
Okay, let me share. Okay, can everyone see that?
Yep.
Excellent. Okay, so as Paul said, January's not been a great month for clear skies. Hopefully February will be a little bit better, but the historically February is not much better than January. So in any case, there are a bunch of interesting things to look for. The title slide, you may recognize this as Kemble's Cascade, which was one of the challenges last month. And I took this picture a few weeks ago during a clear night, and you can see the cascade of multicolored stars ending in the compact open star cluster NGC 1502. So the sun, what's happening with the sun? Well, the days are getting longer, which is always welcome at this time of year. February 1st, sunset was 5:23, and by the end of the month, it'll be 6 p.m. Dawn changes from, gets earlier too. So at the start of the month, the sun rose at 5:53, and by the end of the month, it'll be rising at 5:16. So good for our capacity to make vitamin D. Not so good for deep sky imaging, less dark skies, but on the other hand, the skies haven't been very clear anyway, so it doesn't matter too much. I also note that the altitude of the sun's getting higher, so it increases by a full 10 degrees by the end of the month, which hopefully will bring it above the trees in my backyard so I can do some solar imaging again. Speaking of solar imaging, today's not great, heavy clouds in Halifax, but tomorrow's supposed to be clear. And if you have a scope with a white light filter like Badger Solar Film or Thousand Oaks filter, there's some nice sunspot groups on the sun. This one, AR 2936, is just rotating out of view. It was the source of a number of small solar flares. over the last few days or so. And there's another group just rotating into view. And there's a couple front and center. These particular ones so far are pretty quiet. So there's not much chance of a big solar flare and a coronal mass ejection. But note, I mean, there's, what is it, 5 sunspots currently visible on the sun. And that's holding true for the past little while. Sunspot numbers are now at their highest level in more than 5 years. So it is a good time to get interested in solar observing. There's lots to see on the sun. There is an equatorial hole in the sun's atmosphere, and that's a source of high-speed solar wind, which is causing some auroras, but they're only visible to observers in the Arctic. So hopefully we get some more auroras that we can see in lower latitudes and even in Halifax. This is a hydrogen alpha image of the sun that I copied today from Solar Observatory in Chile. The Daystar site is a good site for daily solar images, just to see what there is. And there's a really nice prominence here, which I'm hoping will still be visible tomorrow if it's clear and I get my solar scope out. So the moon. So the new moon was February 1. The Mi'kmaq term for this moon is the snow blinding moon, Abu Ganajit. You can click on this link. I'm not going to try because it hasn't worked for me before, but if you go to the package on our site on Astronomy Nova Scotia, you click on that and you can hear the correct pronunciation. February 7th is interesting. It's a good time, if we have a clear sky, to identify Uranus, which is going to be just 1.2 degrees north of the moon. And so this is what it'll look like around 8 p.m. So you can will easily be able to pick out Uranus from the other stars in the field of view. First quarter moon is February 8th. Full moon is February 16th. And then at the end of the month, there's a nice wide field of view photo op. On February 27th, Venus and Mars will both be close to the moon, and you can see that in this slide. I took this screenshot from Stellarium, and you can see Venus, Mars, and the waning crescent moon line up nicely within a 10-degree arc. So that'll be a really nice photo op, but you'll have to get up at 6 a.m. And hopefully it won't be too cold if you do decide to get up. February and March are good times to see the zodiacal light if you've never seen it. This is a pyramid of light that in the early spring, so February and March, you can see in the western sky just within about a half hour of the end of twilight. In the spring, it appears in the eastern sky just before the start of morning twilight. So in the fall, September, October. The reason that that these are good months to see the zodiacal light is that it's best seen at mid latitudes when the ecliptic is at a high angle relative to the horizon. But you do need a dark observing sight to see this particular astronomical phenomena. This is what it looks like in stellarium. So on the 19th of February, if it's clear, around 7 p.m., if you have access to a good dark sight, you'll see this glow, this pyramid-shaped, very large pyramid-shaped glow of light after sunset, after twilight. This is a picture I took with zodiacal light last year. I drove out to near 9 Mile River, so the other side of Enfield, and I was able to get a nice shot of on the 13th of March of zodiacal light. You can see the pyramid here, and the Pleiades making an appearance as well. There's a really good article. What's the cause of zodiacal light? It's due to dust reflecting sunlight, and this dust is in the plane of the ecliptic towards the sun. There's a really good article by Roy Bishop in the Observer's Handbook on interplanetary dust, and current thought is that this dust actually comes from Mars. The dust cloud spans the distance from just beyond Mars to the orbit of the Earth. Now, how this dust arises, they're not sure. It's been suggested that maybe the dust storms that sometimes cloak the entire planet may be responsible for that interplanetary dust, but there's no real mechanism to allow the dust to escape the gravity of Mars, but there may be an unknown mechanism. In any case, the dust has to be renewed. I think the calculated lifespan of an individual dust particle is about 10,000 years. So it is constantly being renewed through some particular mechanism. The moon, lots to see on the moon. The first quarter, as I said, is on February 8th. So the nights of February 7th, 8th, and 9th are good nights to, if you want to have a look at any of these features around the terminator of the moon. You can knock off a lot of the explore the moon and explore the universe checkboxes if you have a look at the moon at first quarter. And of course, as you go past first quarter, some of the other features will start to become visible. So the challenge is to observe 3 of the Mare and 3 craters with binoculars at around the time of first quarter. The planets. Well, it's a pretty good month for planets, with the exception of Saturn, which is not visible. You can see all the other planets at some point in the month. Mercury appears just before sunrise, low in the southeast. Its maximum western elongation is on February 16th, and the magnitude is 0.0, so reasonably bright. Venus, if anyone's got up before dawn, you'll note that Venus is now prominent in the dawn sky, magnitude of minus 4.8, so it's really quite bright. Mars is also present in the dawn sky. It's for all of February, you can find Mars in Sagittarius, magnitude 1.3, so it's easily unaided eye visible. On February 13th, there's a wide conjunction of Mars with Venus, And as I noted earlier, at the end of the month, on February 27th, there's a wide conjunction with the moon. If you're going to see Jupiter, better look soon. It's an early evening object in the sky, but it's very near the horizon in the southwest for the first part of the month. And by the end of the month, it's going to be pretty much, you won't be able to see it. It'll be lost in the light from the sun, setting sun. I don't know if we had it, I don't know I don't remember what the sky was on February 2nd, but if you were looking and the sky was clear where you are, you may have seen a Jupiter 4 degrees north of the thin crescent of the new moon. Uranus is in Aries all year, magnitude 5.8, so it's under dark skies. It'll be a unaided eye object. As I said, it passes close to the waxing crescent moon on February 7th. So that's a good opportunity to check off observing Uranus in your observing book. The challenge for the planets this month is to look for or photograph the largest moons of Uranus. They're pretty faint, so they're definitely telescope objects, magnitude 14 to 15. This is a shot from Stellarium showing the location of the major moons, Oberon, Ariel, Umbriel, and Titania. You may recognize those names from Shakespearean plays. But you see how they're going to be oriented around the planet, around the ice giant. And finally, Neptune is still visible. It's low in the west-southwest at magnitude 8, so it's a telescope object. You won't see it with the unaided eye. But until mid-February, it will be visible after sunset, just after sunset. And a couple days ago, there was a conjunction between Neptune and the waxing crescent moon. Winter constellations, these are the same ones that I talked about last month. Auriga, Gemini, Taurus, Orion, Canis Major, and Canis Minor. So nicely lined up, easy to find these constellations. They're quite prominent. Winter stars, again, these are all objects in the Explore the Universe listing. Sirius is very prominent now in the southeast. Number 1 brightest star. A lot of other bright stars there. It's really worth learning the name of these stars if you have a go-to telescope, because they're all good for SIN-SCAN alignment. Just point out this particular star, Gamaiza, this pronunciation right, Gamaiza. It's also known as Beta Canis Minoris. As you can see, it's very close to Procyon. The name comes from the Arabic girdle of the bleary-eyed one. I'm not really sure where that came from, but that's what it is. This particular star is about magnitude 3, so pretty bright, easily visible to the unaided eye. It's about 160 light years from Earth, 3.5 times the solar masses, and it's a blue-white main sequence star. Okay, winter deep sky objects. Got 2 here. I've got one that's an unaided eye object, and the other is a binocular or a telescope object. These are deep sky objects that are also part of the Explore the Universe checklist. If you're working through that program, Messier 45 or the Pleiades is very prominent. It's in Taurus, just above Aldebaran and the Hyades. This particular open star cluster is easily seen by the unaided eye, even in light pollution. So I can step out of to my backyard in Halifax and easily pick out the M45 in the night sky. The challenge is if you're going to look for this, see if you can pick out the 7 main stars, because this is the other name for this particular object is the 7 Sisters, and we had a nice talk last month on some of the how this Messier object appears in different cultures. The Pleiades were or 7 Sisters were the 7 daughters of the Titan Atlas and the ocean nymph Pleione. This cluster is dominated by hot blue stars formed in the last 100 million years. The dust clouds, it was thought that the dust clouds were associated with the stars, but it's currently thought that in fact this open cluster is currently passing through a dust cloud, and that's what's resulting in the nice reflection nebula that surrounds the 7 Sisters. In about another 250 million years, it's thought that this star cluster will have dispersed. So catch it while you can. Okay. The binocular target is Messier 47. This is an open star cluster that's about 78 million years old. So it's even younger than the Pleiades, which are about 100 million years old. There are about 500 members in Messier 47. If you look at Messier 47 in binoculars, if you look 1 degree away in this direction, you'll see another Messier object, another open star cluster, Messier 46. So it's pretty easy to tick off both of those. A bit of trivia. At one point, Messier 47 was thought of as a lost Messier object because there was nothing at the coordinates that Charles Messier originally described. And it turns out a Canadian astronomer, T.F. Morris, in 1959, realized that what Messier had done is he'd swapped a plus and a minus sign as coordinates. And if you flip those around, Messier 47 was where it should be. If you missed seeing Algol, the demon star last month, you can, in Perseus, you can have another look for it this month. This variable star is at its maximum, magnitude 2.1 on February 14th. And then if you have a clear night the next day, February 15th, it will have decreased in brightness to magnitude 3.4 at about 9 o'clock. The entire eclipse for Algol and its orbiting companion star is 11.5 hours. And I think I also mentioned last month another variable star to look for, Heinz Crimson Star, which is a carbon star, and it's a long period variable. So its change in brightness is over a few hundred years, but its variance is quite dramatic, from magnitude 5.5 to 11.7. And I took this picture of the Heinz Crimson Star last month, and in fact, you can see it's a very red star compared to everything else in the field of view. So I think that's all I've got for February. Lots to look at. Hopefully we have some clear nights, and happy to answer any questions.
Okay. If there are no questions, thanks again, David, for another wonderful presentation. And as he mentioned early on, if you want to review what David has said, certainly go to our website, and his presentation is on our homepage. You can just click on it and go through it and review what he has just covered. So thank you.
There you go.
Hey, all righty. So welcome, everyone. There's some news from not only our board, but also from RASC in general that I'd like to bring forward. Again, if you have any questions about this presentation or anything about our center, you can certainly email me at president@halifax.rasc.ca. First thing I'd like to mention is our governance. We have a governance review committee comprising myself, Greg Dill, and Pat Kelly. And it came to our attention during our lead up to our AGM when we had our elections that there were some discrepancies between our bylaw number 1 and this particular policy that we had approved back in a couple of years ago. So that has been corrected. The amendments were approved by our board at its meeting on February 1st, and the revised policy is now on our website. So if you want to read it, if you're really excited about reading policies, go ahead and do so. Under review for the board at its next meeting is our center's membership and conflict resolution policy. It came to our attention through the National Council that National was changing some aspects of its policies related to this. And so we reviewed our policies in relation to what they were proposing changes to theirs. And so our board will be revising this in the coming months. You can look forward to hearing something next month, hopefully, about this being approved. Our Halifax Center Stars, we like to bring forward some of our members or highlight some of our members who have done something spectacular in terms of being acknowledged in not only through our own organization, but through others as well. And Jason Dane, he on January 12th, had the NASA APOD photo of the supernova remnant. Is it Semaeus 147? The Spaghetti Nebula is how I know it in any case. Incredible picture, David. Congratulations Jason rather, on that amazing photograph. And of course, David, I'm wondering if you actually use this in your presentation today, but this came on January 27th in Earth Sky community photographs of the Pleiades. And the equipment he used is noted there. So congratulations, David, on being noted in Earth Sky. Also want to mention about our Nova Notes, our editor, Lisa Ann Fanny, and our copy editor, John McPhee. If you have articles that you would like to submit or have any questions for the editors, you can email them at novanoteseditor@halifax.rasc.ca, and that will go to both of those dear souls. If you have something you'd like to submit, you have until midnight of February 19, that's 2 weeks away, to submit your article or whatever, or a photo or astro sketch. If you're so inclined to do so, please do so. And they'd be happy to include it in the next edition for January, February. Also, we still have calendars available for those that have not acquired theirs yet. They are $25. That includes the calendar plus shipping. Just have to e-transfer it to our treasurer at halifax.rasc.ca or by check to our address. And it's on our website, the address, if you need to want to mail it in. Our meeting dates, they are posted on our website, and notice that we have all the dates for the coming year. We have some speakers lined up. We have potentially one up for April, but I'll have to hold my tongue on that for just a little bit longer until he confirms his availability. But we do have some exciting speakers coming up in the coming year, so look forward to them. And for now, our meetings are being held by Zoom. However, because of the comments received on the member survey that were held in June and November of last year, the suggestion came up that it'd be really nice to get back to in person again. Well, recognizing that we get a lot of audience, not only people that can actually attend physically at St. Mary's University, but also those that attend through the internet on Zoom or whatever. And so we have formed a task team comprising co-chairs Bob Russell and David Lane, along with members Jerry Black and Blair McDonald, who will be looking at what needs to be done so that we can not only, once allowed to be at SMU in person, those that wish to come and visit us in person can do so, but also to be able to provide some mechanism whereby those that can't or won't come into the city will be able to see this live presentation and have it recorded for those that can't be available on that particular date. So we're hoping that everything will be in place so that when we do get invited back to SMU, we'll be ready to rock and roll at that time. Whoops, wrong way, sorry. And also, as I mentioned when Tim was reviewing the Celestron, is if anyone would wish to share their thoughts about their astronomy gear, please contact us. We'd love to hear from you, because that was one of the things as well that the member survey had asked us to look into was, let's provide some information to members about the various pieces of equipment that are out there. Also, we have invited Alan Sutherland from Atlantic Photo Supply, once he gets equipment in, to come to one of our meetings and apprise us of new equipment that's up and coming. So look forward to that as well. So until further notice, our meetings will continue to be held by Zoom. One of the groups that we do work with in the outreach department is the Discovery Center, and they would like us to note to members that the Dome Theater has now reopened. There are 3 live star shows, and there are also 3 featured films. These are mostly geared to the younger audience. Keep in mind that these programs are basically held during the day. It's an in-person ticket purchase only. There's limited seating. Masks are required, and you have to have vaccine proof when you go. RASC News. The total solar eclipse in 2024. Yeah, I know this is only February. However, there has been a RASC solar eclipse task team formed. Paul Gray is from our center and is representing us at that particular task team. And we have to start beginning to think about what are we going to do 2 years hence. So one of the things the board asked me to ask you as a member is, are you planning any events here in the Halifax area or anywhere else in Nova Scotia? And if so, please let us know. Or if you haven't, now might be the time to start thinking about it so that we make sure that you have the resources you require. And are you not going to be here? You're going to be traveling away somewhere else in Canada or to the USA in the line of totality. And if you notice that from the enlargement of the map, totality passes through New Brunswick, the western side of PEI, and if you're really adventuresome to travel up to Meat Cove, you can do so, and you're within the line of totality there. But otherwise, if you're staying here, we'd love to hear from you if you're going to be doing anything, because I think we're about 75 to 85% here. If you have any suggestions for events that you think could be held here, please let us know that as well. Also, February is Black History Month, and the Diversity Inclusivity Committee nationally has an event coming up to celebrate Black History Month. Paul Heath, did you want to address something here?
Yes, we have 3 speakers. One of them is Keith Hewlett, who works at Dalhousie, and they were talking about a lot of their work projects. They'll be talking about, one of the presenters will be talking about outreach and how it affects the STEM program, especially with regards to minorities. And there'll be an opportunity for questions and answers. So on the website should also have the webinar contact and the live stream on YouTube. Now, we're assuming that the webinar will have enough spaces that anybody wants to sign up, they can do that in advance. It should be a good program. Looking forward to having Canadian Black astronomers do presentations on their particular work. and it's a great way to promote the Black History Month for us. So it's well worth signing up for. I believe the connections are on the national website, and you can sign up for it. I'm contacting various classrooms for that, so I'm hoping that a number of students from local communities will be able to have the opportunity to speak with these astronomers.
Thanks, Paul. And yes, it is on the national website, and certainly in the RASC bulletin or the This Week in RASC, one of the two has the link to this, and it's 2 weeks from today. So might want to sign up now as soon as you can.
Yep.
Another thing to mention about the National RASC is they have the return of the Insider's Guide to the Galaxy. And what's really cool about this time around is that they're not only giving you various topics, as you can see there, but also at the end of each segment, they have something called the Messier Minutes. And as you can see from the dates, it's held every 2 weeks. February 1st is grayed out only because it's behind us now. The first one was held, but it is online if you're interested and want to register for the rest of it. But they do present different things at the beginning, and then they cover some Messier objects at the end of their sessions. Along with it, with each session comes a guide that they have a list of the Messier objects they would like you to view over the next 2 weeks, as well as star maps and how to find them. And it's a really great program. So if you're familiar with the Insider's Guide to the Galaxy, their programs are well worth it. Register today. And Samantha Jewett and Chris Vaughn are the two co-hosts. The other thing I'd like to point out is I mentioned earlier about, if you aren't a member, to join us. Well, you can join RASC. And thanks to one of our members who pointed out that, the links on our website didn't work. I had to go in online and figure out why don't they work. So a couple of things have been done with respect to describing this. Number one, if you go to our website now, you won't see the title Becoming a Member. You will see Membership and Renewal. So if you go to our website and see that in the section entitled About Us, you'll see the word join. You can click on that. Or if you go to just go into the regular website of RASC, which is the RASC.ca, you can see on the masthead the words join now. So in either case, if you click on those, you get this page, and it shows the society membership. Choose your membership. So if you want to be a regular, a youth, a family, or you want to give a gift membership to perhaps someone, you would click on the appropriate photo or picture there, and away you go. It'll then lead you through a series of screens that you enter information in order to join. If you are currently a member and you want to renew, well, there's a couple of ways of doing that. Again, through our site or through the national one. You do have to log in initially on the national one, and you still click on that renew membership that you see there in the masthead. And you will be brought again to that screen, but you're not going to click on one of those. You'll see where I've circled at the very top. There was the word log in. Now what this will do is it means you have to log in a second time, but this time you're logging into a secure site. Okay. And that will get you to the dashboard. And you can see in the lower left of the dashboard, the useful links, and you can see the one there that says renew membership. You click on that and then away you go, you fill in the information as per usual. Now, in talking to Pat earlier, the process may be slightly different on your computer. And I do have an understanding that National is attempting to, when you log in as a member initially, that when you say renew, it will automatically bring you to the secure site. You don't have to go through that intermediate step, but you may have to for now. So be aware of that. But you're one of these dear souls that prefers to really do business in person. You really don't want to do the online stuff. The best way to do that is to email them at mempub@rasc.ca. Let them know who you are. In other words, your name, perhaps your membership number, and an email address or a phone number if you want them to phone you, to contact you to do that by phone. And if you need assistance, keep in mind, we do recognize that during COVID times, there are some folks being out of work require financial assistance. If that is the case, email them at the same email address, mempub@rasc.ca, and they will certainly have the funding to assist you with that. And keep in mind too that RASC has moved, and that is on their website. You'll be able to see their new address there as well. So that's the changes in how to become a member and how to renew. The perks for the Halifax Center, certainly you get to be a member of our discussion list if you so choose. And you can do that either through digest method, or if you want the emails coming in one at a time, that is your choice. Please do so. And you certainly have access to our St. Croix Observatory. Any questions? Okay, if not, thank you everyone for attending today. We've had a great audience. We had a great speaker. Thank you again to Jennifer West and to Tim Doucette for being our guest speakers. We look forward to next month with another set of speakers that I know will enthrall you. So thank you, everyone. And with that note, Pat, you can stop recording and everyone is welcome to join us on the Astro Chat.